Dear students, I welcome you for the today's lecture related to the gaskets. After the understanding of the flanges, the need of the gaskets one can understand. So in between the flanges, to prevent the leakages, we are putting a soft material, and that soft material that can be considered as a gasket. So its basic purpose is to prevent the leakages between the two flange joints. You can see in this figure the gasket which is available in between. This is nothing but a gasket which is available in between these two flanges. So every flange joint that is in between the every flange joint, the gasket that is available. In this figure also you can see the gasket that is available. So this is the closed two flanges are bolted tightly. In the previous figure two flanges are separate. So here the two flanges are tightened. Now we are going to understand what are the gaskets, why gaskets are used, where these gaskets are used, which materials are used for gaskets, then properties of gasket material, how does it work, how does the gaskets work, then the types of gasket, selection of gaskets, and the application related to the gasket that we are going to discuss. So first, what is the gasket? A gasket that is specifically used to fill the irregularities between the two flanges or two mating surfaces on the machine part. It is not necessarily that we are using these gaskets in between the flange joints of the pipe, but also in the machine parts where two metal parts they are clamped. In between that also the gaskets they can be used. So gasket allows less than perfect mating surfaces on machine parts where they can feel the irregularities. Gaskets they are commonly produced by cutting from the sheet. The different sheets they are used and they are given the proper shape. The gasket is a mechanical seal basically. Its purpose is to seal the fluid so that the leakage should not be there. So to prevent the leakages in between the two mating surfaces which feels the irregularities, and it serves the purpose of a mechanical seal. So it is usually desirable that the gasket can be made from a material that is to some degree yielding such that is able to deform and tightly fill the space for which it is designed. When we call it to fill irregularities, that means it has to get deformed, means it is going to change its shape. कॉम्प्रेस होता है तो सो दैट इट विल गेट डिफॉर्म. जैसे आप उंगली को प्रेस करते हैं तो कुछ तो चेंजेस आपको ऑब्जर्व मिलते हैं आपके ओरिजिनल शेप में. सो शेप गेट्स चेंज. देयर इज अ सर्टेन डिफॉर्मेशन व्हेन यू प्रेस these two fingers. So the deformation that helps for feeling the irregularities in between the two mating surfaces. Now here also you can see the yellow mentioned, that is the gasket connected in between the pipes. Then why gaskets they are used? That is the basic purpose is to avoid the leakages of the process fluid and serves the purpose of sealing. So flanges they are necessary basically to connect in between the two materials, connect in between the two pipes. So even though the flange face is carefully machined, there can be the surface irregularities. That is what is most important thing to be understood. That is the flange surface. It is a metal surface. Even though it looks soft and one cannot see the uneven surfaces, but to a smaller scale, there are small uneven surface on that metal surface. So when two metal surfaces they come in contact, there will have the uneven surfaces and which helps for the leakage of that material. So to fill these uneven surfaces on the flange faces, these surface irregularities are to be filled by deforming the gasket. So cracks of the faces, even when you tight these two flanges, it's a hard material. There is a possibility that these flanges may get broken when you are going to tighten with a high pressure. There is a possibility of cracks of the faces. So the purpose of gasket is to provide the seal and thereby avoid the leakage of the process fluid from the equipment of the pipes. Then when the gasket is placed on the flange face and the joint tightened by the bolt, the gasket gets compressed and then permanently get deformed. So deformation of a gasket because of the application of the force, which is the tightening of a bolts. We apply a force to tighten the bolts of the flange, and this applied force forces the deformation of the gasket material and seal the surface irregularities and prevent the leakages. So any metal surface look like perfectly mating. However, small gaps, pores exist. So to prevent the leakage from these pores, gaps, a flexible second deformable material is used to fill the gaps, pores, thus preventing the leakage. Then which are the different materials for gasket? So gaskets are prepared from the flat sheets, basically a flat sheet, a paper flat sheet. This I can use as a gasket. I will cut it into the desired shape. I can cut this paper sheet into a desired shape and can be used as a gasket. So a paper sheet that can also serve the purpose of a gasket. Sometimes the cloth that is also will serve the purpose of a gasket because it gets deformed and seal the surface irregularities. Then the paper, rubber, cloth, asbestos, cork, plastic, silicone, then soft metal, fiberglass. All these are the different materials that can be used for gasket. Now, out of this, rubber and paper and cloth, they're primarily used, and also the natural rubber, then the cork, and nowadays the plastic, which can be neoprene, nitrile rubber, polytetrafluoroethylene, and the different types of the plastics which can seal the surface irregularities and which can sustain the pressure and temperature conditions can be used as the gasket material. Besides that, the silicone that also acts as a gasketing material, and the soft metals which are used at a higher temperature. So soft metals like copper, aluminum, nickel, lead, soft iron. So these are the different soft metals. They can be used for as a gasketing material. Nowadays, even fiberglass that is also used. Then what must be the properties of this gasketing material? One major thing that it should get deformed and should seal the surface irregularities. So that material should be the soft one so that it can be easily deformed. It can be easily change its shape and can flow into the surface irregularities. So the gasket is a compressible material or combination of a material. It can be a combination of material also. It is not necessarily a single material that will be used always. It can be a single material also, or it can be a combination of the different materials, which when clamped between the two stationary members prevent the passage of media across these members. It is usually desirable that the gasket can be made from a material that is to some degree yielding such that is able to deform and tightly fill the space it is designed for. Then the gasket material selected must be capable of sealing the mating surfaces, resistant to the medium being sealed, and able to withstand the application of temperature and pressure. So it should be able to seal, it should be resistant to the medium, that is the operating fluid. It should be able to withstand the temperature and pressure conditions. And most desirable property of an effective gasket in industrial application for compressed fiberglass material is the ability to withstand the high compressive load. That is also, it should not get damaged because of this tightening. So it should be able to withstand the high compressive load for a longer time. That is also essential. So most industrial applications involve the bolts exerting the compression load. Then how does it work? Basically, it gets deformed and are able to flow and fill the surface irregularities. So a seal is effected by the action of force upon the gasket surface. This force which compresses the gasket causes it to flow into the flange macro and micro imperfections. That is, causes it to flow into the flange micro and macro imperfections. So that is the combination of contact stresses generated by the applied force between the gasket and the flange and the densification of the gasket material prevents the escape of the confined fluid from the assembly. So these are the different pictures of gasket. It's a different material. Here you can see the specifications related to the this gasket. It is made of two three materials, different materials. This is made from the asbestos with the metal mesh inside this asbestos, and these are the most commonly used gaskets cut from the sheets and given the desired shape. These are the most common gaskets. The selection of gaskets. Now in this figure, if you can see the gaskets, they can be of different shapes. As the flanges have the different shape, so similarly the gaskets also can have the various types of the shape. The gaskets can be classified, one type of the classification, that is the soft cut, then semi metallic and metallic type, that is the one type of classification we will discuss in the detail afterwards. The physical properties and the performance of a gasket will vary extensively depending on the type of gasket selected and the materials from which it is manufactured. Then what are the important physical properties that the gasket should be taken into consideration or selection? That is your temperature, pressure, corrosive nature of the application fluid, and the criticality of the application. That is also whether it's a hazardous process or is it a normal process. Depending on that, I have to select the gasket. So primarily it is the temperature. That means the temperature of the process media or the presence of the media, compatibility of the gasket material for the media and its application. So the temperature, depending on the temperature, this is the primary requirement, which material that can withstand the material which can withstand the fluid temperature. Depending on this fluid temperature, one has to select the gasketing material. So in selection, this process, the temperature of the fluid at the gasketed joint should be considered first. Then when the system operating temperature approaches a particular gasket material maximum continuous operating temperature, what should be the maximum continuous operating temperature of a particular material? If it is approaching this operating temperature, then one can upgrade the quality of a material and use the superior material also. Then the media, this is the basically the which chemical is being used in the process. Depending on that media, I have to select the material of the selection for the gaskets. The gasket should be the strong enough to resist the internal fluid pressure. It should be also resistant for the corrosive nature of the media. Then the maximum temperature and pressure capabilities do not necessarily operate together for all the gasket thicknesses, and it is recommended that the pressure and temperature are considered simultaneously while selecting the material. So limit of the gasket for different gasket thicknesses. Now what should be the gasket thickness? In general, the gasket should be the of a minimum thickness. So it should be the minimum thickness gasket should be preferred. For the gaskets cut from the sheet, always use the thinnest material which the flange arrangement will allow, but the thick enough to compensate for unevenness of the flange surfaces. It should be thin, but it should not be that thin so that it will not be able to feel the surface irregularities. The quantity or the thickness of the gasket should be sufficient so that it should be able to feel the surface irregularities. So thinner the gasket, the higher the bolt load. Thinner the gasket, I will require the higher bolt load for tightening. And the gasket, if it is able to withstand that load, then it is well and good. And the less the loss of the bolt stresses due to the relaxation. As it gets deformed, it gets relaxed. So also the gasket area will be lower, which will be exposed to attack from the internal pressure and aggressive media. So it should be the minimum area that will be exposed. So if it is in between the two flanges, I am putting the gasket here, and this is the exposed surface area for the fluid. This exposed surface area for the fluid, that should be the minimum one. That is what the gasket area will be the lower, which will be exposed to
Uh,
attack from the internal pressure and the aggressive media. Also, in the view of this, ensure that the gasket is as thin as possible. So you can see the different gaskets. Now coming to the classification of the gasket. The gaskets, they can be classified as the conventional gaskets, self-energizing gasket, then the welded type gasket. So this is the classification of the gasket, that is the conventional gasket, self-energizing gasket and the welded type gasket. Now in the conventional gasket, it is the soft cut gaskets, the composite gasket and the metallic gaskets that is there. Conventional, that is routine we are using. In that category, soft cut, it is the most simplest. We are cutting it from the sheet. Then composite gaskets, that can be permutation and combination of the two different materials. A composite that is formed. And thirdly, a metallic gasket. So soft cut gaskets, these gaskets are cut from a flat sheet to a desired shape and size. So it's basically a sheet that will be used and will be cut into the desired shape. So materials can be cut easily using conventional tools and techniques. I can use the scissor, I can use the different cutting tools to give the desired shape. Then sheet material are also used in low to medium pressure services. With careful selection, these gaskets are not only suitable for general service but also for extreme chemical services and temperatures. Then the complex geometric shapes can also be prepared from these sheets. Then gaskets are easy to install and can easy for its removal. All the products are non-toxic. Then thickness of the gasket used in the range of zero point 0.4 millimeter to 3 millimeter. Zero point 0.4, a very small thickness of the gasket that will serve the purpose, because unnecessarily it will increase the bolt load. So 0.4 millimeter to 3 millimeter thickness. The types are the flat ring gasket, non-asbestos fiber sheet, then PTFE insulating gaskets, flexible graphite gasket, asbestos gaskets, then plastic paper, rubber cloth are used up to the 120 degrees Celsius. Now there are the limitations of the temperature to which I can use this material. This plastic, paper, then rubber, then cloth, these are used up to 120 degree Celsius. Then asbestos, a cork, which can be used at a slightly higher temperature than this plastic, paper, rubber and cloth. So asbestos, that can be used up to 250 degrees Celsius. And above that, one has to select the specially designed metals or the different specially designed uh, metal, soft metal gaskets. Then the composite gaskets. So these composite gaskets consist of both metallic and non-metallic materials. So it's a combination of a metal and a non-metal. The metal provides the strength and the resilience of a gasket, while the non-metallic component provides the conformable sealing material. So both the purposes, it should have the strength as well as it should get deformed. When we consider the deformation of the material, that material should be the soft one. But when we are considering it's a soft material, then it will not have the strength. So we are making a combination of a metallic and a non-metallic material. So metal that provides the strength and resilience, and in non-metal provides the easy deformation, the comfortable sealing material. These gaskets are suitable for low and high pressure and temperature applications. The wide range of materials are used. The spiral wound gaskets, cam profile gaskets, then metal jacketed gaskets, metal reinforced gaskets. These are the different types of the composite gaskets. The next is the metallic gaskets. These gaskets can be fabricated in a variety of shapes and sizes, and they're recommended for use in high pressure and temperature applications. So metals are used at a high temperature and pressure applications, and these are only the soft metals they are preferred, which get deformed, and generally the thickness is on lower side, say 0.3 mm to 1 mm is the thickness of these metal gaskets, 1 to 2 mm. Except for welding gaskets, the high loads are required to sit the metallic gaskets, as they rely on the deformation or coning of the material into the flange surface. These are the ring type joint, lens ring, weld rings, solid metal gaskets. So these are the different metal gaskets. Depending on the different designs, industrial uses, and chemical contact and physical parameters, the gaskets are divided based on the sheet gasket, then the laminated or metal jacketed asbestos field, then solid material gaskets, then corrugated metal gaskets, then spiral wound gaskets, then constant sealing stress gasket, then double jacketed gaskets, then cam profile gaskets. This is the again the different type of the classification that is there. The sheet gasket, laminated or metal gaskets, solid material, corrugated metal, spiral wound, then constant sealing stress, the double jacketed cam profile gaskets. So these are the simple sheet gaskets, that is the solid sheet that is used and given the desired shape. Then the sheet gaskets, these are simplest in the sheet material of the gasket, and it is punched out from that. This leads to a very crude, fast and cheap gaskets. It Previous time the materials were compressed asbestos, but in modern times a fibrous material such as the high temperature graphite that can be used. So basically the asbestos they are used and nowadays this graphite that can also be used. These gaskets can fill the many chemical requirement based on the inertness of the material used and fit many budgetary restraints. Then the common practice prevents these gaskets from being used in many industrial processes such as the temperature and the pressure concern. Then the solid material gaskets. All these are your different types of the combinations of the gaskets, different metals are used. Here it's a solid material of the gaskets. Now if you will look at this gasket, it is the punch holes that is provided for the bolt area. That is the difference between this gasket and this gasket. This these gaskets are inside the bolt. However, this gasket is covering the complete flange surface, covering the complete flange area, and that is why these bolts they are provided. The bolt area that is also cut, and here you can see the different specifications related to the gaskets that is also defined. Then the solid material gaskets, the idea behind the solid material is to use the metal which cannot be punched out of the sheet but are still cheap to produce. These gaskets generally have a much higher level of quality control than the sheet gaskets and generally can withstand the such higher temperature and pressure. Then the key downside is that a solid metal must be greatly composed in order to become flush with the flange head and prevent the leakage. The material choice is more difficult because the metals are primarily used. The process contamination and the process oxidation are at risk. The gaskets metal used must be softer than the flange in order to ensure that the flange does not wrap or flange does not get cracked and thereby prevent the sealing with the future gaskets. Even so, these gaskets have found a niche in the industry. So these are the spiral wound gaskets. Now all the gaskets, when you look the standard gaskets, then who had manufacturer's name that is to be embossed on this gasket, then the winding material and the filler material that is to be used, that is 316L, that is the stainless steel that is used here as this winding material, and in between the stainless steel rings, it's basically the rings, uh, spiral rings are there, and in between these spiral rings the PTFE material or the asbestos material or the rubber cork material that can be used depending on its temperature and its application. So these are the stainless steel rings, and in between the stainless steel rings the material that will be feed, which will be uh, sprayed. Then the outer ring material that is also there. This is the outer ring material, that is the 316L. This in between inner ring material that is also there. So inner ring material, then the sealing element, which is nothing but the spiral arrangement that is provided. So this is the inner ring. You can see the labeling for this, that is the inner ring that is available, the outer ring that is available, and the sealing element that is available. So inner ring, this will be exposed to the fluid surface, and in this case it is made of a 316 stainless steel. Then outer ring, that is also made of a stainless steel 316R, and the inner sealing element, the winding material is used, and there is a filler material that is also used. So this winding material is again a stainless steel 316, and filling material is your PTFE. So these are the arrangement, and it is not necessarily always that there will be the inner ring, there will be the outer ring, and there is a spiral sealing element. It is not necessarily always that all the three components will be there. There can be the sealing element and the outer ring that will be also there. Generally the outer ring is available, inner ring may or may not be there. Then besides that, the diameter and the pressure class that is also mentioned related to this standard gaskets. So this is the 4-inch gasket that is available, and it can be used up to 150. That is the pressure rating that has been mentioned. So these are the different specifications related to the gasket. So here you can see the sealing arrangement, the metal sheet, stainless steel metal sheet that will be available, and in between these two metal sheet, the PTFE or the sealing arrangement that will be available. So I can feel the different material here as shown in this black portion. So this is the sealing arrangement that will be available. So it can have the different permutations and combinations of here the metal strip that is there and the fillet material that is also there. So this is the metal sheet, stainless steel round, and the fillet material that will be in between these two stainless steel. Then these are your spiral wound gaskets. All these are called your spiral wound gaskets. So because there is a spiral winding which is available, and when you look at this is the spiral sealing element is nothing but a spiral winding that is available. So this is the winding material. It's a spiral winding. Different layers they are prepared. So the spiral that is wound gaskets comprise a mix of a metallic and the filler material. Generally, the gasket has a metal, normally the carbon rich or the stainless steel, that is wound outwards in the circular spiral. So, outside this periphery, spiral periphery, the outer ring that is there. So, outer ring that is there, and there can also be the inner ring also. With the filler material wound in the same manner but starting from the opposing side. This results in alternating layers of the filler and the metal. The filler material in this gasket act as the sealing element with the metal providing the structural support. Then these gaskets have problem to be reliable in most applications and allow the lower clamping forces than the solid gaskets. So basically when we are using the spiral gaskets, it is having the uh, higher cross-sectional area. So here the area that is get compressed. Here the metal, solid metal outer ring is there. Its height difference is there. All this you can see the certain height difference that is available. So we'll have the higher so in this figure, you can see the inner spiral ring which is available is having the higher thickness as compared to this outer ring. So this is you can specifically see the thicker diameter which is available. Then double jacketed gaskets. These are the double jacketed gaskets are the another combination of the filler material and the metallic material. So in this application, a tube with the end that resembles a C is made of a metal with the additional pieces made to fit inside the C. So this filler is pumped between these shell and the pieces. So this is your shell which you can cover from up and from the bottom part, and in between this filler material that is filled, and that is why it is called the double jacketed gaskets. The jacket that has been made in this. Then cam profile gaskets. These are the solid corrugated cores with a flexible covering layer. So as the solid corrugations are available there. And when you apply the pressure, these corrugations get damaged and gets deformed, and which helps to prevent the sealing arrangement. So these cam profile gaskets are used in many older seals since they have both the flexible nature and the reliable performance. This cam profile works by having a solid corrugated core with a flexible covering layer. Then this arrangement allows for very high compression and can extremely tight to the seal along the rings of the gasket. Then since generally the graphite will fail instead of a metal gasket, the cam profile can be repaired during the latter intensity. The cam profile has a higher capital cost for most applications, but this is the countered by the longer life. So these are the costly. These cam profile gaskets are costly. Then coming to the uh, gasket joints. So these gaskets, they can be of a full face gasket, then gasket within the bolt circle, the gaskets with a simgot and socket arrangement, or you can say the tongue and groove arrangement, and the O-ring. So these are the full face gasket. The first figure that corresponds to the full face gasket. So this is the full face. Complete face of the flange is provided with a gasket, and that is why it is called a full face gasket. Now in this full face gasket, the bolts will also have the area that will be provided. So if it is the gasket, then the bolting area that will be also available for this gasket. So it is compulsory to provide the bolting area in this full face gasket. Then there is a gasket within the bolt circle. Means gasket within the bolt circle. This is for the bolt circle diameter that will be there, and before that the gasket is available. So flange faces will be in contact to this much area only, not complete area. Here the complete area that will be there, the flanges will be completely covering the one another, and in the gasket within the mold circle diameter, that is only the one surface area which is in contact, or the raised surface area of the flanges, that will be there. That is the raised surface area of the flanges. There we can see the gasket that will be there. The simgot is socket arrangement, that is also called the tongue and groove, that is there. So in the groove, the gasket that will be available, and the tongue compresses that gasket so that the leakage will be prevented. Next is the O-ring gasket. So a certain O-ring that has to be made, a circular ring that will be provided or fitted in between the grooves uh, provided in the flanges. So all these are the different gasket joints. Then there is a metallic gasket that is also available. They can be fabricated from a single metal or the combination of the metal materials in a variety of shapes and sizes. And these are generally used for the higher temperature and pressure applications. Also the higher loads also can be accepted if I'm going to increase the thickness. In this, the ring type gasket, lens ring, and the welded gaskets, these are the different common type that will be used. The ring type gaskets that can be of metal as well as can be of the rubber also. Then the ring type gasket, that is the solid metal gasket, provides an excellent mechanical joint and has almost universal acceptance in the oil and petroleum petrochemical processing industries, where the high mechanical and thermal performance that is required. So the type of the R oval conformation is the original ring joint design, and was followed by the type of the R octagonal. Okay. Then lens ring that will be also there, used for high pressure. Then welded ring gaskets that will be there. Now the self-energizing gaskets. This self-energizing gasket, in that the double gasket that will be there, then delta gasket that will be there, lens type gaskets, and these are the self-energizing gasket. That is, the pressure cooker. We are using the gasket, right? The ring somebody says it ring, it is nothing but a gasket. But you can very easily and easily remove it and again fit it back. This also works on the principle of a pressure. So as the inside pressure that increases, this gasket gets expanded and seals occupies the available space. So that is also the self-energizing gasket. So because of the internal pressure, it gets expanded and can occupy the surface irregularities and prevent the leakage.